Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Two Equations and Three Unknowns. It's a medium problem. You guys can pause and go over the problem once. So just to explain the problem real quick, we're playing this game with this other person where he picks three random numbers, X, Y, and Z, and these are given as natural numbers, right? And our goal is to figure out these three numbers. And in order to do so, what we've been allowed is to come up with two combinations. So first combination would be A comma B comma C, and the other one is also A. So I'll just call them A dash, B dash, and C dash. Right. Now what happens is, so we give the person this combination, and he tells us the result of the linear combination AX plus BY plus CZ. Right. And now having known this, we come up with a second set of A comma B comma C, and then the person again gives us the answer of the linear combination, right? And having knowing these two values, we have to somehow deduce the values of x, y, and z. So we'll go over an example just to clarify everything. So imagine the person in front of us picks numbers 5, 66, and 11 as x, y, and z, right? And we randomly just choose a comma b comma c to be 1 comma 1 comma 1, right? So what the person is gonna tell us is actually 5 plus 66 plus 11, which is going to be 82, right? So we tell the person 1 comma 1 comma 1, and the answer we get is 82. Then we have to come up with another set of a comma b comma c. So for example, this time we could say 0 comma 0 comma 1, right? And this time we get the answer of 11. So having known these two values, 82 and 11, we somehow have to figure out the values of x, y, and z. Now, naturally, we'd expect there to be three equations and three unknowns, right? But here it's different. So that's why this problem is a bit tricky. I'll give you guys a few hints. So one of the very first hints I give you guys is to focus on the fact that it's given that those three numbers, x, y, and z, are natural numbers. This will come in handy. What I'm trying to say by natural numbers is that those numbers are somewhat bounded. Those can only be 1 or greater than 1. A second hint I'd give you guys is to understand the fact that we are allowed to choose the linear combinations, or rather the equations, right? We are allowed to choose A, B, and C for both the equations. So this is slightly different to a simple problem where we would have been given three equations and three unknowns. It's different in the fact that the numbers are natural numbers, so they are bounded in some sense, and also that we get to choose the the equations in some way. So we first give them a set of a comma b comma c. We get the answer, and knowing that answer, if we're clever about it, we could use this answer to cleverly think about the new set of a dash comma b dash comma c dash to get another value. And using these two values, we could deduce x comma y comma z. So now I'll be talking about the solution, the actual algorithm that we could implement to figure out the three unknowns. And by the way, this algorithm that I'm just going to talk about, it's such that even if the entire question was the same and there were four unknowns, it would still work, or rather five or six, or all the way up to n unknowns. So n could be any number, any natural number. So taking the example of 5, 66, and 11 again as x, y, and z. Imagine I took ABC to be 1, 100, 10,000, right? So the first answer that I'd get from the person in front of us would be this summation over here. And there's something special about this value, right? We can see 11, 66, and 5. Now what I did over here is I chose such coefficients a comma b comma c such that the three numbers 5, 66, 11 came in the total sum as it is. Like 11 came as it is, and then 66 came as it is, and then we got 0, 5. And from 0, 5, we could reduce 5, right? So we can see the three values x, y, and z directly. Now, why did this work? Well, it's first of all, To get the numbers as they are, I chose powers of 10, right? So 10 is power 0, 10 is power 2, and 10 is power 4. So that when multiplying with them, multiplying the value with the x, y, and z values, they don't change. Now it's also important that this addition doesn't overlap with this value over here, and this value doesn't overlap with this value, right? So I'm also having to make sure that these values are really separated. So to make a counter example, let's say the x, y, and z values were 512, 66, and 11. This time 100, and 10,000 wouldn't work. Why? Because this time around, the first sum that we'd be told would be this value over here. And this does not help us in any way possible, right? Because it's not representing the three values x, y, and z. So this is why it's really important that the three numbers x, y, and z have to be separated enough such that the values come out as it is and there's no overlapping. This overlapping over here between the 5 of 512 and 6 of 66 made this problem, right? So we also have to make sure that these values are large enough. So we've got one thing that we have to use powers of 10 and we have to make sure that the values are large enough. Now, how do we ensure that the values are large enough? And also remember that we have been given the liberty of two such summations, right? Currently, I'm just using one. So now what we're going to do is to figure out the largest of the three. So for values x, y, and z, if we somehow figure out the largest number among these three and take the length of that number and call it d, and if I now choose the values 1, 10 raised to power d, and 10 raised to power 2d, this will guarantee that the numbers are separated out enough such that the summation will have, so within the first digit, we're gonna have x, within the next d digits, we're gonna have y, and within the last digits, we're gonna have z, assuming x, y, and z to be likewise, right? So just to conclude the algorithm once again, first we're gonna have our ABC values as 1, 1, 1. What's this gonna do is gonna tell us the answer of a plus b plus c. Now, having knowing a plus b plus c, we can take this sum and just take d to be the length of this sum. Now d is guaranteed to be a length larger than the length of the biggest value among x, y, and z. Because d is the length of the sum of a plus b plus c. Sorry, by a plus b plus c, I mean x plus y plus z. So we took values 1, 1, 1. We got the sum x plus y plus z. Of that summation, we took the length of that summation, call that as d, in order to have a length that is big enough that we can ensure that for the new summation, which is going to be 1, 10 to the power d, and 10 to the power 2d, the sum that we get this time around is going to have x within the first d digits, going to have y within the second d amount of digits, and z among the last d digits. And we can thus just answer the values of x, y, and z directly. I'd also recommend you guys going over the official solution. It's the exact same solution, so it's just written in formal words. Hope you guys understood the solution, and thanks for watching.